Every November, deep in the Adirondacks, DEC fisheries staff are hard at work. They are spawning landlocked Atlantic salmon, a native salmon species found in New York State. The work they do will ensure that the species thrives for years to come. Built in 1885, the Adirondack Fish Hatchery is the second oldest hatchery in New York State. It is also the only state-run hatchery in the Adirondack Park. Originally, the hatchery raised a variety of trout species, but became a monoculture for landlocked Atlantic salmon in the late 1970s. The hatchery was rebuilt in the 1980s to its current design. All landlocked salmon raised at this facility are stocked throughout New York State. Not only does Little Clear Pond provide the wild broodstock for the Adirondack hatchery, but it is the hatchery's primary water source, providing over 2,000 gallons per minute. The production building at the hatchery contains 16 14,000-gallon tanks. Each of these tanks can hold up to 2,000 pounds of salmon, or 24,000 6.5-inch yearlings. 4 of these ponds are used to raise captive broodstock. These broodstock are fish that are kept from every other year class to provide eggs. All captive broodstock are stocked out after 5 years. There is a long history of stocking landlocked Atlantic salmon in New York State, with efforts dating back to the late 1800s. Many New York waters are stocked with landlocked Atlantic salmon to provide recreational fisheries for this popular sport fish. They are the same species as the sea-run salmon, but like the name implies, they remain in freshwater their entire lives. They remain one of the most highly regarded sport fish in New York. Landlocked salmon are found in water bodies all across New York, including the Great Lakes, Lake Champlain, the Finger Lakes, Catskills, and many lakes and ponds in the Adirondacks. Every year, during the second week of November, the egg collection process begins with the hatchery staff setting Oneida-style trap nets around Little Clear Pond. In total, the hatchery has 8 nets. 6 of these nets are set at certain locations each year that have had the highest catch rates. The other nets are experimental nets. These nets are set at different locations each year to monitor any changes in the areas of the ponds that are utilized by the salmon. How the nets are going to work are we have a leader that runs the shoreline. Fish are cruising around the shoreline looking for a tributary. They bump into the leader. They follow that leader back into the net. The farther they go into the net, eventually becomes a funnel. That funnel drops down into what's called the car of the net, or the bag of the net, where the fish will remain until we can tend it. The nets are left for 48 hours to allow time for fish to collect in the car. These nets measure 6 feet tall, which allows for each net to hold hundreds of salmon. Because unlike Pacific salmon, Atlantic salmon do not die when they spawn, so once we go through this, they go right back into population and we're going to catch the same fish next year. So we have several year classes in here. I've seen 5, 6, 7-year-old fish come back every year. We have a tending crew out right now, so they're going to go back and forth bringing back the broodstock fish. When the live well is full, the boat will return to the dock where other staff are ready to begin processing the fish. Yep. The first thing they're going to do is they're going to sex them. Males have that kype, that lower jaw that extends beyond the top jaw, and they're usually a little bit longer, a little darker. Females are going to be a little bit more robust. They have all the eggs in them. After the fish are sorted by sex, a person will then net 10 to 15 females and place them in anesthetic. Fish are anesthetized to minimize stress while allowing easier handling, ultimately increasing the number of eggs collected. Once anesthetized, they are rinsed off with clean lake water to remove any anesthetic. Care is taken not to drip excess water in the bowl. Once an egg is exposed to water, the fish culturists only have a limited amount of time to fertilize the egg. The eggs are then gently squeezed from the females by pressing on the abdomen. It will take 2 to 3 females to fill a bowl. Once the bowl is filled, males are netted and gently squeezed to fertilize the egg. Because the anesthetic may negatively affect the milt or sperm, the males are not anesthetized. Once the milt has been stripped, the males are then placed in the center cage to be stocked back into the lake. Once we do all that spawning process, we have the Region 5 fisheries staff here. They're doing all the biological data. The data recorded includes length, weight, sex, and fin clips. The fin clips identifies what year the fish was stocked. This process will be repeated every other day until the quota is reached. On average, the wild broodstock will produce 250,000 eggs. The next day, hatchery staff switches gears and begins processing domestic females, which are located inside the production building.
We're using the domestic females today are going to be the 3-year-olds and the 5-year-olds we have over here. On off years, we're going to be using 4-year-olds. What we have is we have a crew out there on the lake still. They're still taking the milt out of the males.
They are fertilized with the wild males that were not stripped on the previous day. To remove milt from the males, fish culturists will net one fish and use towels to dry off any water on the fish. Because the milt must travel from the pond over to the hatchery, it is critical that it does not come in contact with the water. When it comes in contact with water, it is only viable for about 60 seconds before it loses motility and will no longer fertilize an egg. The fish are then gently squeezed into dry containers, once again ensuring no water is added. After the males are stripped, they are returned back to the pond unharmed. The milt is then transferred into transport containers and brought to the production building for use. It is critical to test the collected milt for motility before spawning the fish. Hatchery staff check the milt under a microscope to confirm the batch is viable. Even a drop of water can be enough to make the whole batch unusable. To test it, a drop of milt is mixed with a drop of water to verify that the milt activates.
Once we verify that, we have spawners that are going to be stationed here, squeezing females. Typically, we can get about 2 to 3 females per bowl. Depending on the size and the age of the females, we can get anywhere from a 3-year-old fish can have about 2,600. 4-year-old fish have typically about 4,000 eggs per fish, and then 5-year-olds have about 5,000 eggs per fish. We're going to squeeze it into the bowls, add a little bit of milt to it, give it a swirl, allow for about 30 seconds for fertilization to take place, and then once we did it yesterday, we're going to dump it into the iodine bath and let that sit until we bring it to the back.
The iodine is absorbed by the egg, which eliminates any bacteria or viruses. Before the incubators can be filled, the eggs must be counted. To do this, the hatchery uses a Von Bayer trough. The trough is 12 inches long and V-shaped, which allows the eggs to form a single layer. The line of eggs is then counted, and a chart is referenced to determine the number of eggs in an ounce. Typically, 64 ounces of eggs are placed into each tray, and depending on the size of the eggs, each tray can hold 8,000 to 10,000 eggs. At maximum capacity, the incubation room can hold 1 million eggs. However, depending on New York State's needs for landlocked salmon, the number of eggs held varies from year to year. After the quota is reached, the eggs will remain in the incubator trays until they hatch. While in the trays, any bad eggs, which are white, are removed using siphons. These bad eggs are caused from a lack of fertilization, poor egg development, disease, or fungus. From 24 hours after fertilization until the eyed egg stage, the eggs are in what is called the sensitive stage. At this stage, the embryos are vulnerable to physical and temperature changes. Depending on the water temperature, it will take at least 1 month for the eggs to develop eyes. At this point, they have reached the eyed egg stage and can be handled, picked, and shipped. The first pickoff has the highest mortality rate and can range from 1 to 35%. Because of this high volume, the eggs are placed in an automatic egg picker. The egg picker separates good from bad eggs and can sort up to 100,000 eggs per hour. It accomplishes this by shining a small light into the egg. If the egg is good, the light will pass through the egg. However, if the egg is bad, the light will be blocked. A small burst of air will eject any bad eggs, and the good eggs are collected into a separate bucket. In mid-January, the eggs will hatch and become sac fry. The newly hatched sac fry are transferred to raceways while they absorb their nutrient-filled yolk sac. Once the sac has been absorbed, the fry are fed once per hour. During this time, the fish will grow rapidly and will almost triple in size in 4 months. In June, the fish will measure 3 inches and are now considered fingerlings. Because they will outgrow the capacity in the raceways, they're transferred to the large rearing ponds in the production building, where they will remain until the following spring to be stocked out as 6.5-inch yearlings.